Hello guys. What more I wanna say? Yes, according to the other video that I made on this wing rig, today I'm going to show you the breakdown of the wing rig. To get started, we are in the model scene for this character, which is the scene that my code picks up for the riggings. Okay. Um, First thing to note is she's in this pose while the rings are in this other pose, right? The rings are like modeled as if she was in T pose. Now, the reason for that is that I didn't want to move away from rigging in this pose because I think it's very good for certain parts, especially shoulder area. I think it just looks more natural if you have it like that. But this, I think it's a lot better to rig if it's in a nice T pose, elbow down, arms straight out, very easy. So I placed it like that, and then in the code I add a little bit of a thing that snaps the rigged T pose, rigs the wing stuff, and then puts it back into the bind pose, and then it finalizes, but that's towards the end. So to show you how to start this, the first thing was, well, the modeling of these feathers, and the modeling was a little bit of a back and forth thing. I cheated a bit, I have to admit, because I did not rig to unfinished model. I developed both of those things more or less at the same time. So I'll show you here something quickly. Wing rig scene objects. Alright. So we got here a little stuff that is already in the model scene. I have this group here called build scene objects that contains all the stuffs that my rigging code needs later on, rigging wise, but it can't auto generate, so I have to make it myself. This is one of those things. So if we isolate this quickly, you can see it's just a plane driven by a bunch of joints, right? And the way it's driven, so how I can get these nice looking, very smooth deformations of this plane is I look at this. So I just duplicate this mesh, right? That's the duplicate of the mesh. Let's just delete that first shape and go in and make the intermediate non-intermediate. You can see this is what I started with. Okay. And let's just do that. Okay, so I started with this. I skin one vert to each joint, and then that's then this mesh. I subdivide, smooth the mesh 2 times so I can get nice in between edges and stuff. I keep everything live as is, and then, oh my god, I have actually very nicely deforming high-res mesh driven by just a bunch of joints. Alright. The next step is the way I laid out the feathers. So after I did this with the feathers roughly in place. They were really quite well in place at that point. But then I went ahead and just took each feather. At that state, they would also be in individual feathers, and just rotated it so it aligned perfectly with one of these edges. Right. So there's one feather, one of these primary and secondary feathers per long edge. Okay. These middle small feathers, they're not really that important if they, I didn't pay too much attention here in modeling, so it's not really accurate, but it doesn't really matter if they don't align with the edges, because skinning later will take care of that. Then I made this bit here by duplicating a bit of the arm geo, extruding it down a bit, and adding this nice like cover feathery texture. Simple stuff there. And that's it, right? So we did the model here, okay? So we've got our feather model in place. At this point, the feathers are still individual models, especially these big ones. These small ones you can already combine at this point. But these big ones, it's good to have a copy of this where you have the feathers all separated. You can also do that after the fact. It doesn't really matter for the coming steps. Okay. So once we did that, we rig everything, right? So I rig the body, put the body in T-pose, and then I rig the feathers. So let's just go open rig scene so I can show you the other stuff. Okay. Come on, load the shaders. There we go. Loaded all the shaders. Alright, and in here you can see what basically it did is it created a little rig for each of the main driver joints. Let me just turn on affected highlighting. Alright, so I have a little ball here that makes the base joint aim towards it, and then I have little offset controllers that just point constrain the joints. Alright. But actually, before I explain all this rig stuff, let me explain this. Right, so now we magically just got a joint per edge on that big plane. And the way I did that is, if we just go into this module and have a look. Alright, let's isolate that. Rig wing. Alright, yeah. So basically, it generated a curve. You can see there's the curve. Generated a curve for each edge of the surface, and I found a couple of challenges while coding that up. First one was left and right side don't get the same component IDs. So like what I did was I had this surface. Let me just pull it up. Okay. So I had the surface here, you know, and it had like its edges there. So basically the core of this is you just like get all those edges and then go to like modify, convert smooth mesh preview to polygon edges to curve, right? So I used that command, and I just want like the thing to do that. And so my first attempt was to just do it manually once, get all the edge IDs that I need in a two-dimensional array, with like the top index being each row, and then the bottom index having each edge for that row. Stupidly enough, that didn't work, because when I then mirrored the mesh and wanted to redo this thing on the right side, this poly smooth face outputs a different vertex and edge component ID order in general. So my array on the left side didn't work on the right side anymore, and that pissed me off so much already that I was like, I'm not gonna make another array for the right side specifically. I need to proceduralize this better. So the second thing that I did then that actually worked was let's go to the modelings, check the UV editor. So this is how the UVs are laid out for this mesh. It's really nice uniform stuff. So what I did is just I wrote a little UV space sampler that lets you iterate through the UV space in UNV counting U and V samples, and output you the vertex closest to that UV coordinates. So it's literally like a nested for loop twice. You know, you loop through the number of samples, so through 1 divided by the number of samples times the indexer. For U and for V, you get your closest vert, you convert that to edge, and there you have your edges. And that worked pretty good for left and right meshes alike, because they have mirrored UVs, right? Because I just mirrored them over, automatically, boom, they're mirrored. UV here is the same as UV there, so that worked. Right, so after doing that, I was able to get my edges converted to curves, and then on those curves I generate joints, as you can see here, and then I drive these joints by ikspline, driven by that curve. Next little challenge was the up vector, right? Because if I select all these joints, maybe without those, just these joints, just pick the end one for have little more clean display, and I just show the local rotation axis. You can see how they oriented, and they're oriented pretty nicely. Okay, but it wouldn't stay that way because of the ikspline, because that by default just orients to world, and so basically if your character rotates around, the joints will just rotate themselves to conform to the new world orientation. So I had to find a way to get the ikspline up vector going well. And what's a better way than to use the advanced twist controls? Awesome shit. Okay. Before I came to doing this, I tried lots of other things, like interpolate the vector matrix for each control or onto the closest IK based on the distance and stuff like that. Some crazy shit, and it all didn't work. Oh no. And it all didn't work very nicely. And then I figured, hey man, I have this mesh. Why don't I just get the mesh normal to dictate my thing? So then I went and did that. So basically I just create a follicle on each of the base verts of this mesh, and then I get there we go, follicles, you can see them there, and then I just get the output normal of this follicle and feed it into the up vector of the ikspline, and then you get very nice, whoops, let's not do that, you get very nice up vectors. So basically if I rotate this, you can see how the bones follow the orientation. And I figured, because it doesn't change much here, right? So if I did that, that didn't change much. I have to rotate like from the base, and then you can kind of see it happen. But as you can see, it's a little buggy, because it's taking the base, and the base normals obviously are a bit different than the end normals, so this kind of goes off. So if I show this, it still works, right? The feathers still kind of do what they do. Let's hide that bit, and this, let's just go with turn double-sided off. Alright, so you can see through this crap. Right? Boom. So you can still see the feathers do what they do, and it kind of works, but you can see also that they don't rotate perfectly. So this is something that I will still fix. And the way I'll fix it is I'll just generate a second set of follicles at the end vert and then instead of using the vector, whoops, I just use the vector start end, and then I just feed the end word into the vector 2. That's it. Very easy. Just like 2 lines in the code to change to fix that. But yeah, that's how this works. So when everything here is set like that, right, we have the surface, and it's driven by the big joints that drives the small joints with all the crap that I just said, and then that drives the feathers, right? So we skin each feather to each joint. So I literally just select all the joints on each chain, skin them to the feather using closest, using just selected joints and closest point and all that simple stuff. I do that for every feather, and when I'm done with that, I just combine the meshes with skinning. A new thing added in 2016, I suppose. Mesh, combine skinning, and that'll actually combine your meshes, preserving your skin cluster so you can delete non-deformer history after that without the loss of skinning information. So I did that, and then I basically just saved the skinning, and then it gets loaded back in by the code on build time. So I didn't need the separate model anymore, so that no longer exists in the model scene. But then all you have to do is like copy the skinning from these feathers to the smaller feathers, soften it out a little bit. I use ng skin tools to do that, and then that gives you already nice results. Like the feathers, even the small feathers, that just interpolate between stuff, still preserve their length, or their width is the width actually quite well. Yeah, and then for as far as the rig goes, again the long main joints are controlled by these controls. This control here is point constrained by a point here on the arm and orient constrained to the chest. It has a little space here, right? So you can change the orient space to arm, chest, and so on. Oh, I'll explain also later. Oops. I'll explain later the other stuffs for the attributes on these controls. But then I've got this Alula control here, which is separate from the hand. It's driven by the arm instead of the hand, because especially on this character, again, I wanted the hands to have no influence on the feather bits, right? Because she still needed to articulate with the hands and, you know, move them around and do stuff without this, like, the end bit of the wing going whoa, whoa, whoa all the time, right? So that's disconnected there. Right, let's just set that back to that. So this Alula control just controls that end stuff, right? Okay, so this end control is driven by, obviously, this Alula control, which is driven by the forearm. This control here is driven by the arm and by the forearm. So you can see this is enum attribute, and I have the space that drives it, so I can see I can blend between the two spaces, arm and forearm, and then I can even go further and go like to chest or something like that. So if I put it on chest, even if I rotate this guy, you can see this stays oriented to the chest until I rotate the chest, right? But I figured a nice space is just having it at 0.5 in between arm and forearm. Yeah, then this guy here I mentioned is driven by the chest, and then these two guys here are set to be in between this guy and their corresponding corner things. So the way I did that, there's plenty of ways you can do this. I wanted a fairly proceduralized and stable way of doing this though, because what you could do is, you know, just orient constrain between this guy and that guy, but 0.5 and that. might work, but our constraints blending is a bit unstable. Though you can change the interpolation mode to shortest or something like that, it's still no guarantee for flipping less interpolations. So what I went for is aiming. So this guy is aiming constraining from here to a point here that is being point constrained between this guy and that guy, and the ratio of the point constraint is set to the ratio between the distance of this guy to that guy and this guy to that guy. So I can point constrain with no offset, and instead of the point landing right in the middle, which would be somewhere here, it lands here, which is the distance measured from this point to that point to that point. So that allows me to move this guy like that, and you can see this guy will always be exactly between these two other guys. And then obviously the same game on the other side. It was a bit of a challenge to get that point, because basically, since I wanted to have it quite automated, I didn't want to have to manually pass him in a reference point. I wanted it to do it automatically. So the way I do this is a bit cheaty, it's a bit hacky and unclean, but I just make a curve object from here to there, just a 1D curve, boom boom, and then I get me the direction of this guy based on this guy's joint, right? So we have this vector and this curve, and now I just want to find the point along this vector that is the closest to this curve. I did some nifty stuff, some iterative stuff in the code, having a point here, translating it down by the initial distance between the point and the closest point on the curve, and then as I just translate it down along that distance, and hang on a second. So basically, yeah, but that's the distance to the closest point, which might not be where I wanted it to be. So I have to then do it a couple of times, that with some maths behind it, until I get the point that is closest to this line actually. Yeah, because basically from this vector in that direction down by this distance might not be the closest point to the actual curve. So I had to do a bit more there. But it was actually quite close. There was a difference between like point something values, so it would have been negligible, but I wanted it to be as accurate as possible, so I went with a little bit more complex way of doing it. Anyway, all of that crap literally to just have these controls be in the middle of the wing, of the other two driver controls. Okay, yeah. So the other thing, a couple of attributes here. Bulge is literally just what bulge does is it just a connection to the translate Z of these two controls of this chain. So if I go up a bit, there you can see translate Z, and that comes from multiply node for the bulge. Right, so if I do bulge, it'll just translate on that offset group. If I do bend, it'll do a very similar thing. It'll just move the guys, the end from the end a little bit up and down, and it'll be decreasing exponentially, so that I can get a nice bend from the wing like that, right? So that's bend Y, then bend Z is basically the same thing, but like along the wing actually, and not along the wing normal. Right, so I can get that kind of stuff going. But yeah, again, it's just a connection to a couple of transform offset nodes on these controls. Then roll and twist is a thing that connects into the IK splines, as you can see here. And this is again interpolated. So, because I only have 1, 2, 3, 4, 5 controls, but I have 17 IK spline nodes, I had to do a little bit of stuff. So basically what happens is I get for each spline IK handle, where I get me the for the end joint of each spline IK handle, which is like the joints along this curve, I get me the 2 closest controls, right? So from the control array, I just found a little thing that gets me the n closest things to a point, and I just get the 2 closest controls. And that procedure also returns the distances for each object. So doing that, I can measure the ratio between the both controls distance to the IK. So I can just add, like, put that ratio in a blend attribute when I blend the multipliers for this roll, right? So if I do roll, for example, you can see feathers will rotate a lot on here. Actually, they will rotate a lot on both because I have both selected. If I deselect this guy, do the roll, you can see they rotate fully there, and then they gradually decrease the rotations. Because the distances for the blend of the ratio between these things got interpolated. And then the same thing goes for the twist. I basically use the same values, right, and that just twists it. Last thing, the stuff, let me just go here because we need this. These objects have a texture deformer for the fluttering. Now this guy is not finished because I haven't quite finished the code here. I'm a little lazy on there, but basically all I have to do is just save me a map. Whoopsie. Texture deformer. Let's just save me a map of the weights that I'm about to make. Right, something like that. So basically all this is it's a texture deformer piped in with noise texture, a couple of settings here that I made for this noise texture, and then it gets driven by this Alula control. So flutter strength feeds into the texture deformer's how's it called, envelope, and then the flutter time feeds into the noise texture node's time attribute. So I can simply do the fluttering like that, right, and that just gives me a nice flutter. Yeah, I'd say that's pretty much it for the rig breakdown. That's how everything works, and it's stitched together down in the code, and it works pretty well for me. Only that one thing that I just figured out is make the IK spline use 2 vectors at start and end to have a little bit more stable feather behavior, even though it doesn't disturb me that much right now. How it is, but anyhow, that's pretty much it. So yeah, she gets snapped into this T-pose, then all of this building happens, and then she gets basically snapped back. And because of the rig, it just works, right? So the wings just look like this in her default pose, but that's alright, I don't mind, because from here I can do all the things that the wings need to do. Like I have this other animation. Just a quick animation that I did yesterday, testing this rig. A little bit of a play around with flight cycles and landing. So yeah, I mean that's just a very quick animation for flying and landing. Can look a little bit better at it if I just mute this guy. Translate. Whoops. Yeah. So I do a little bit of FK switching here, so the legs go a bit wonky because I muted the TZ on the thing, but not on the IK feed, so they're still moving wide. But yeah, that's pretty much it. It was a little bit of a proof of concept animation, see if I could get it to work and behave and move alright on the wings, and actually I did, because this was not really a long to animate it. It doesn't look very nice from a professional animation standpoint, I'd say, but it's a nice proof of concept. The wings kind of work. Animation needs a lot of work though, but it can be done with this rig, right? So that works. Yeah, so that's it from this video. If you have any questions regarding this, send me, and I'll see you in the next one.